Okay, shall I start?
Good morning, sir.
Good morning. So, shall I start today's class? Okay, up to the last class, you have gained a lot of knowledge, and if we take it serially, you can find that. Suppose first of all we have to apply some load. Okay, so number one, we have to apply some load on a particular structure, and then we have to go for analysis the structure. Okay, and this structure, maybe it is a determinate structure or it may be indeterminate structure. Okay, no issue. So for both case, if you analyze the structure, you are doing actually you are calculating the bending moment, shear force, torsional force, axial force, like that. Okay, and based on the performance of the structure, you have to find out all those parameters. So you can find bending moment, uh, shear force, and axial force, and you can find say torsional moment and torsional force. Sorry, you can find torsion, and all those parameter. Please keep in mind, we can say that this is nothing but actually stress resultant. We called it stress resultant. Okay, we called it stress resultant. Now for beam or for frame structure, you can find bending moment, shear force. Okay, and no axial force is there, no torsional stress is there. And when you are going to analyze the truss like structure, okay, so truss element, you can see that we calculate only the axial force. Okay, and when your structure is say a primary beam subjected to a secondary beam, then torsion will also coming, no issue. So all those parameters are actually stress resultant. Okay, now based on bending moment, we are now, this is the focusing point at right now, because we are designing the structure against the bending moment, because this is the actual strength criteria. Okay, this is the strength criteria. Now to do this, we have two material. One is concrete, and that is steel, and both have stress strain curve, different type of stress strain curve. Now Who is Lucky Jaiswal? Hello? Hello?
Yes, sir. It's me, Sunny Kumar. Sunny Kumar, sir.
Sunny Kumar. Okay, okay. And today I have to check all those name of your of the student, okay? Because previously I have a bad experience. Sunny, you change your name, okay? Otherwise, it will be
Okay, sir.
impossible.
Sir, my default email ID is just changed. That's why I didn't log in that account.
You just create another Gmail, okay? No issue. Then you can.
Yes, sir.
join.
Yes, sir. From tomorrow I will do it.
Okay. And FLR
Yes, sir.
Gaming.
From tomorrow I will do it.
Okay. FLR Gaming. Hello.
Sir, I am FLR Gaming, sir. I am Bobby.
You just create another Gmail ID. Okay.
Yes,
No
yes,
issue. With your name. Okay. No issue.
sir.
Keep it as it is, FLR Gaming, and you just create another Gmail ID with your name.
I'll-
Okay, okay. Now,
Sure.
yes. Hello. Hello. Hello.
Yes, sir. Yes, sir.
Tell me what.
Hello. Yes, sir. We can.
Okay, okay. So now, the first step you please keep in mind. The first step is we have to apply the load, and the next step is analysis of the beam. Okay. So analysis of structure, and you can find bending moment, shear force, axial force, and torsion like that. And based on the bending moment, based on those stress resultant, you have to design the structure, and you have to use the two material. One is concrete and that is steel. Okay. Now the next step after designing, the next step, the final stage is you have to calculate the dimension. Please keep in mind you have to calculate the dimension. Okay. You have to calculate the dimension. That means for concrete you have to calculate B and D. So width of the beam and depth of the beam. And for reinforcement for steel, you have to calculate the total area first of all, and based on this area you have to calculate the number of reinforcement. Okay, number of reinforcement. This is the final stage, and actually this is not final stage. After beyond that there is so many steps are there. You will learn step by step, no issue. Now if you think total procedure simultaneously to do the design, we have some methodology. We are using a working stress method, and later on we are going to use limb state method. Okay, and IS code have the guideline of the stress of the concrete and stress of steel. Okay, so from table 21 you can find the permissible stress of concrete, and from table 22 you can find permissible stress of steel. Okay, now what about load? The load, you have to apply the load, and how what should be the value of the load when you are going to design a particular structure. Suppose this this is a frame structure consists of 4 beam and 4 column. Okay, so those are support. And you have to design, suppose this beam, you have to design this beam. Now what load you have to apply, you have to choose. Okay, now the method, please keep in mind the name of this method is working stress. Working stress method. Okay, now what does it mean? Working means working condition. When the beam is in working condition, that means in the lifespan of the beam, the load which is coming on this beam is the working load actually. Okay, so what should be the working load? Working load is number one is dead load of this particular beam, self weight. Okay, self weight of this beam. Okay, another is dead load. If there is a slab, then self weight dead load of this slab also coming on this beam. Okay, number three is imposed load. Okay, if there is any live load or any furniture load, so imposed load will come. Number four, if there is any wind load in horizontal direction, then some bending moment will create on this beam. Okay, so wind load will also coming. If there is any earthquake load, then this load will also coming. Okay, so all those load will come on, and it will affect the bending moment of this beam. Okay, now this there is number of load. Okay, and if you consider any particular load, there is, suppose we are considering only self weight of the beam of this particular beam, self weight of this particular beam. If I consider the self weight means nothing but UDL. Okay, you have performed a beam which is subjected to a UDL. Okay, it is simply supported beam and subjected to a UDL. This UDL nothing but a self weight of this beam. Okay, now you can find the bending moment diagram. So this is the bending moment diagram, parabolic one. So this is the maximum bending moment. So due to the self weight, there is a bending moment. Okay, due to the self weight of another element of this structure, there should be another bending moment. Okay, so due to the another, suppose live load, there should be another bending moment. Okay, if there is another wind load, there should be another bending moment. So due to all separate load, you can calculate a number of bending moment also. But which one you have to take? All those, between all those bending moment, which one you have to take? Now please keep in mind, we generally do not take any one particular bending moment or the maximum of those. Okay, because for a particular time, suppose at right now, this is impossible to apply only one load at this beam. Okay, because a self weight is also there. Suppose this beam is a slab is there over this beam. Okay, now due to the slab, one self weight or of the slab will coming on the beam, and the beam has itself another self weight. So these two load will act simultaneously. Okay, and suppose at the daytime suppose this is a office building, so at the daytime all three force will come. Okay, now at some season there is very wind flow is there at a particular season, so at daytime this all this force will come. Okay, now due to the between the lifespan of this beam, so lifespan is beam of the structure, lifespan of RC structure, we generally assume that is 50 year. Okay, 50 year is the total lifespan of any RC structure. Okay, now in the lifespan of the structure, maybe some earthquake will happen, then all those load will come simultaneously. Okay, but should I consider all those load or not? It is the another problem. If I consider all those load, then the structure will be safe, it's okay, but the problem will be created, that is the structure will not be a economical structure. Okay, this will be very costly. So there is two governing criteria to design a structure. Number one is the structure should be safe. Okay, safe, and another criteria is structure should be economical. Structure should be economical. So you have to, when you are going to design a structure, you please keep in mind your structure should be safe and your structure should be in economic condition. So the structure should not be costly. So what should I do at right now? Should I consider some load or should I consider all load? So you see that if I consider all those load, if I consider all those load, the structure will not be a economical structure. Structure will be very costly. Okay, so we have to assume some type of load here, that structure will be safe also and structure should be economical also. Okay, now I want to show you IS code. Please let me open the IS code. You please look at this table carefully. This table 18, page number 68 of IS 456. Okay, this table gives you the value of partial safety factor for load. Partial safety factor, what is partial safety factor? I'll tell you later. So there is three column. One is load combination, another is limit state of collapse, another is limit state of serviceability. Okay, now you don't think about limit state of collapse at right now, I will discuss later. Okay, now this is the, you just see the this column, limit state of serviceability. Now dead load plus live load, the load combination is this DL means dead load and IL means imposed load. Okay, and WL means wind load. Okay, so dead load plus imposed load, the combination is 1 for dead load and 1 for imposed load. That means 1 multiplied with dead load plus 1 multiplied with live load. That means we are considering the dead load and live load as it is coming on the structure. You got my point? Now dead load plus wind load, again we are considering 1 multiplied by dead load plus 1 multiplied by wind load. So we are actually considering the dead load and imposed load in one combination, and dead load plus wind load in another combination, and there is another combination is dead load plus imposed load plus wind load. That is 1 plus 0.8 1 multiplied by dead load plus 0.8 multiplied by imposed load plus 0.8 multiplied by wind load, and you can see there is no earthquake load here. Okay, so in this case you can see that the note is here: while considering earthquake effect, substitute EL for WL. That means if you consider earthquake load, just change the WL with EL, that means earthquake load. That means earthquake load and wind load cannot act simultaneously. We do not assume this. We assume that the dead load wind load and earthquake load do not act simultaneously. Okay, either wind load will act, otherwise earthquake load will act. Okay, why? Because in our past history, wind load and earthquake load simultaneously happen. There is no any this type of history in our history. There is no in this type of case wind load and earthquake load are acting simultaneously. That's why we have to keep in mind the economical condition criteria. Okay, keeping the economical condition criteria, we can neglect between either earthquake load or wind load. We can neglect one. Okay, that's why dead load plus imposed load is there, dead load plus wind load is there, another we can say that dead load plus earthquake load is there, another we can say that dead load plus imposed load plus wind load is there, or dead load plus imposed load plus earthquake load is there. Okay, you got my point. And for those case, you can see for limit state of serviceability, the factor is 1. That means we are considering that amount of load which is coming on the structure in the service lifespan of the beam or of the structure. Okay, so what is the now the analysis procedure is actually, suppose this is your beam and you are going to analyze this beam. Okay, now in real life, when you are going to design the structure, you have to consider dead load of this beam plus imposed load, and you have to analyze this beam and you can find one bending moment. Okay, so for the second case, again you have to analyze this beam with dead load plus wind load or earthquake load, and again you can get another bending moment. Okay, another case you can then the third step is you just add dead load plus imposed load plus wind load, and again you calculate the bending moment. Okay, now those are the load combination, and you can see the multiplication factor always is 1. Okay, for this case this is 0.2 for this is 0.8 and this is 0.8, and for other case all those multiplication factor is 1. So we have to consider the maximum bending moment. We have to consider the maximum bending moment from this. Okay, maximum one. Suppose this is the maximum, so you can consider this maximum bending moment. Suppose this is the maximum, so you have to consider this maximum bending moment and you have to go for design. Okay, now at the previous semester or at right now in your structure analysis, what you are doing, you are calculating this type of determinate or indeterminate structure, and the load is actually given. Okay, suppose in the question there is suppose there is a point load or there is a UDL load, the load is given to you. But in real life structure, you have to calculate the dead load, live load, wind load, like that. Okay, you have to calculate. But there is another problem: we cannot calculate dead load. Otherwise, we don't know the actual dimension of the beam, and actual dimension of the beam, that is B multiplied by D. Actual dimension of the beam we don't know actually, and we have to find out through the design. Okay, now what we can do, we can assume some dead load. Okay, we can assume generally we assume some dead load, and live load is imposed load will coming from the purpose of the structure. If it is a commercial building, there is a certain rule in IS 875 part 2, what should be the imposed load. If this is a residential building, there is a guideline in IS 875 part 2 for imposed load. What should be the imposed load is there. Okay, so you have to follow IS 875 also. This is IS 875. Okay, so it's when they say part 1 is for dead load, part 2 is for imposed load, and part 3 is for wind load. Part 3 is for wind load, and part 4 is for snow load. You don't require at right now snow load. Okay, so in hilly area when snow load is coming, then you can use this part 4, and part 5 is the load combination. This load combination is also given in part 5. Okay, and there is another special case of load. So the special load plus load combination, those are given in IS 875 part 5. Okay, now what about earthquake load? There is another code of earthquake load. Okay, no issue. Now you can notice that I have said you the factor multiplied with dead load with live load. Okay, this is 1. That means when we are considering a structure, in our real life, when the lifespan is 50 years, in between the 50 year, the load which is coming on the structure, we are actually considering this load only. Okay, please keep in mind, we are actually considering this load which is coming. Suppose in the 50 year 100 kilonewton load will come. Okay, so it will never exceed 100 kilonewton. It will come only 100 kilonewton load will come. So we are considering this 100 kilonewton load. What does it mean? That means we are not increasing the amount of load. That means if in 50 year of lifespan, say one day the applied load exceed 100 kilonewton and it becomes 150 kilonewton, or 120 kilonewton or 110 kilonewton, what will happen? We are designing the structure considering the 100 kilonewton load, and in the 50 year of lifespan, suppose one day 120 kilonewton load will come. What will happen? IS code is saying that your structure will fail because you are considering 100 kilonewton load, and 100 kilonewton load is coming in the service lifespan of the structure. So when load is applied on a structure, what is the result? The result is nothing but stress in terms of bending stress, in terms of shear stress, in terms of direct stress, in terms of torsional stress, like that. Okay, so various type of stress is there, but the actual result is stress. Actual result is stress, and this stress is developed. This stress is developed due to this load. This stress is developed due to this load, and this load is actually in the working under the working lifespan. Okay, this load is coming. We are not increasing the load. That means if the load exceed the applied load, we have to consider the structure will fail. So if I go through in backward direction, then what is happening? The 50 years is the service lifespan, and this service life in this service lifespan we are considering this amount of load. Okay, and due to this load the stress is developing. Okay, now this service lifespan means the beam offering the serve its performance. The beam serves its performance. So this service lifespan indicates the working condition. After 50 years, we have to assume that after 50 years the structure will collapse, or the structure is not capable to carry any load. Okay, so this 50 year is our working lifespan, I should say. So in working lifespan we are considering some load, and due to this load this stress is happening. That's why it is called working stress. Okay, so why working stress? The name is there because in this lifespan we are considering the actual working load. Please keep in mind actual working load which will come between this 50 year, 0 to 50 year. This working due to this working load stress will develop. So that's why we call this as a working stress method. Okay, now just see if what is the drawback of working stress method. This is the stress strain curve of concrete, and this is the stress strain curve of steel, and we are considering this is actually parabolic one. Okay, this is actually parabolic one, and there is a little bit straight line is there at the very beginning. There is a little bit straight line. Okay, now we are considering this level. You know that we are considering this level of stress in working stress method. Okay, and we are assuming that, suppose we are assuming that 100 kilonewton load will come. Now you tell me, if the load exceed 100 kilonewton and it becomes say 120, 130 or 150 like that, it becomes, then what will happen? Will it collapse or not? Say suppose it is 150 kilonewton. Okay, Now what will happen? If I increase the load, that means the stress developed, stress of concrete or stress of steel will also increase. Okay, now this stress in IS 456, there is a limitation of concrete sigma CBC, and there is a limitation of steel sigma ST. Okay, so beyond this you cannot go. That means you cannot consider in your design. You cannot consider in your design. Please keep in mind, there is difference between you are considering in your you do not considering in your design, and this will not happen in the life in the actual real life structure. There is difference. That means you cannot go beyond this limit. It's okay, but if load exceed 100 kilonewton, if load exceed 100 kilonewton, then stress will also increase. Actually it will not fail. Okay, IS code is saying that you cannot go beyond sigma CBC and sigma ST, but if load exceed 100 kilonewton, that is we are considering during the design of the structure, what will happen practically stress in concrete will exceed the sigma C or sigma CBC, I should say sigma CBC, or this is sigma ST. Practically for the 150 kilonewton load, say sigma CBC 2 or sigma ST 2, and this is obviously greater than, sorry, so this is obviously greater than this. So if we exceed the applied stress, then obviously in our real life structure stress will also go to increase. Okay, and IS code provide us only this limitation for concrete and only this limitation for steel. So where is the sigma CBC 2? Where is sigma ST 2? Where it is? What is the position of sigma CBC? We can say that this is beyond this, but we cannot determine, we cannot calculate the actual position of sigma CBC 2. We cannot calculate. Okay, sigma CBC 2, where it is? It may be in this layer, maybe in this layer, maybe in this layer. Okay, so for sigma ST 2 we can say that sigma ST 2 is above the sigma ST provided by IS 456, but where it is? It is maybe it lies in this layer, maybe it lies in this layer. Okay, maybe it lies in this layer, I don't know. That means if the structure at any time, at any moment in the lifespan of the structure, if the structure experience the load which is greater than the applied or assumed load, assumed design load, I should say, the structure, if the structure experienced any kind of load at any moment in the lifespan of the structure which is greater than the design load, then if the structure will fail or not, we cannot determine. You got my point? We cannot determine, we cannot predict that what will happen if the structure experience greater than the design load. It will fail or not. Say sigma CBC, maybe sigma CBC is at this position, so it will fail. Okay, or if the sigma CBC 2 is in this position, so it will not fail. Okay, now you cannot calculate this amount, you cannot calculate this range. In this range you cannot calculate. Okay, the value of sigma S or value of sigma C in this range you cannot calculate, because IS 456 strictly prohibit this range. IS 456 giving you the limitation up to this point, okay. So up to this point, so this is one drawback of working stress method, that is we cannot predict the actual failure behavior of the structure. We cannot predict the actual failure behavior of the structure in working stress method. This is the number one drawback. Okay, and number two drawback is the you can see from the stress strain curve of concrete or stress strain curve of steel. The material can resist this much amount of stress. This is the highest stress. Okay, this is the stress line and this is strain line. Okay, this is a strain line and this is stress line. So material can resist this amount of stress for concrete and this amount of stress for steel. Okay, now we are considering this level. In working stress method we are considering this level, so we are totally neglecting a huge amount of strength of the material. We are neglecting huge amount of strength of the material. Okay, we are neglecting. That means we are going to waste the material in working stress method. Okay, we are just neglecting the strength, means we are just going to waste the material. The material is wasting in the, I should say the stress is wasting in this working stress method. This is another drawback. Okay, now all those drawback will eliminate in our limit state method. Okay, when I go to limit state method, you can understand how we can eliminate all those drawback. Okay, now there is a difference. You can see there is difference of number one is load, number two is material. There is difference. What is the difference? The difference is like that. For this case we do not consider the load, the certain extra amount of load we do not consider. We are considering only that amount of load which is coming on the structure, say 100 kilonewton. For this case we are considering that amount of load. Okay, so we are not going to multiply any factor that can increase the load. If I increase if I design this beam, considering 200 kilonewton load, then we can say that in our service lifespan in 50 years, if we suppose we can calculate, we can analyze that in our 50 year the load is coming on the structure is 100 kilonewton, but again we are considering the we are designing the beam with assumption, that is the load that is coming on the beam is 200 kilonewton. So what will happen? We can say that this beam will never fail. Okay, this beam is absolutely safe, because we assume the design, we assume the 200 kilonewton load, and we design the structure. That means this beam will never experienced 200 kilonewton. It will always below the 200 kilonewton, and in our 50 years, say this is a 100 kilonewton load maximum. Okay, then we can say that the structure is safe. But we are not doing that. We are actually considering this amount of load. That means we do not apply any safety factor. We do not apply any safety factor in the load. Okay, please keep in mind, we do not apply any safety factor in the load. When we are if we apply any safety factor in the load, that means we have to assume this load as a higher than the applied load. We have to assume like 200. Okay, so when I say that I am going to apply a safety factor on load, that means, you please keep in mind, that means the load should be greater than the applied load. Okay, load should be greater than the applied load, and we are not doing that in working stress method. And the second phenomena is that we are considering very less amount of strength for concrete and for steel. We are considering very less amount of stress for concrete and steel. That means we are applying a safety factor for steel and concrete. Okay, so suppose this is the highest amount of stress and this is the highest amount of stress, and both material are actually produced, one in a field and another is in industry. One is in field for concrete made in field. Okay, and steel made in industry in proper laboratory, proper environmental condition. Okay, now for both case we can say that, suppose we ordered a M20 grade concrete. We ordered a M20 grade concrete. Okay, so we cannot say that this is absolutely M20 grade. We cannot say that. Okay, so what we have to do? We have to assume this strength of concrete is less than this. Strength of concrete is less than this, not beyond that this. Okay, and when we ordered this, suppose 250 Fe 250, we ordered Fe 250 grade of steel. Okay, now we cannot say that this is actually 250. Okay, for material again we have to assume that the strength of the material is below that I considering. That's why we are just considering this lower value of stress. Okay, now we are again applying a safety factor for material. Okay, we are applying a safety factor for material and we do not apply safety factor for load. Please keep in mind. Now one thing you can see, when I said the safety factor for load, it is always, this safety factor is always greater than 1. It should be greater than 1. Okay, and when I say the safety factor for material, okay, it should be less than 1. Okay, when it is greater than 1, then we can assume that the higher amount of load, and when this safety factor is less than 1, then only at that time we can assume the less amount of strength. Okay, so there is two safety factor. One is for load, another is for another is for material. And in our working stress method, we are applying the safety factor only for material, not for load. Okay, for load and for material. So there is no safety factor, and we are applying the safety factor here for material. Okay, and always the safety factor of load is always greater than 1, and safety factor for material is always less than 1. Okay,
Sir,
yes,
11 होएगा 11 AM.
okay, just 2 minutes.
Okay, sir.
Now this is one problem of working stress method, and this is absolutely singly reinforced beam. Also, a rectangular beam section of 300 mm width and 500 mm depth is reinforced with 16 mm dia tension bar, and determine the stress induced in the top compression fiber of the concrete and tension steel when it is subjected to a moment 50 kN meter. Consider concrete grade is M20. So in this case, the depth, that is dimension of this beam, is given. Okay, dimension is given. So one is the width is 300 millimeter, and depth is, it is not actual depth, it is always effective depth. Okay, 500 millimeter. Okay, now reinforced with 16 millimeter dia tension bar. So there is 1, 2, 3, 4. Okay, four, 16, 5 tension reinforcement. Okay, determine the stress induced in the top compression fiber of the concrete and a tension steel when it is subjected to a moment 50 kN meter. Consider steel grade, concrete grade is M20. Now another data is bending moment. Bending moment is 50 kN meter. Okay, another data is concrete grade is M20. Now for concrete grade M20, you can find in table 21 of IS 456 the value of sigma CBC is how much? It is 7. Okay, so next day I will show you the code. Okay, and next day I will complete this problem. Okay, no issue.
Okay, sir.
You
Sir,
just
tomorrow. Next.
Yes, yes.
200.
Yes. So you just please keep in mind, we have to calculate, we have to determine the stress in compression fiber, that means concrete and steel. That means we don't know the value of actual value of sigma c and sigma s. We don't know actual value. Okay, we have the limitation of concrete. This is 7 sigma cbc. That means this is the stress diagram, and this distance is sigma c, and this distance is sigma s, and at this position, this value is actually sigma c. Okay, and at this position here, say suppose this value is sigma st. We don't know. Okay, so we have to calculate this one, we have to calculate this one, and again we have to calculate this neutral axis depth. Okay, and we have to calculate the lever arm also. Okay, so this is lever arm, we have to calculate. Again, all those parameters we can calculate. So in the next class I'll show you how we can calculate all those parameters. Okay,
Sir, effective date cover to go.
cover is here. Okay, this is the cover. There is two type of cover is there. One is clear cover, and another is effective cover. Effective cover means, suppose this is the reinforcement, this is the concrete, and this is the reinforcement. Okay, so this distance is actually clear cover. Okay, and this distance actually effective cover. Okay, now in the next class I shall show you in details. Okay,
So I understand.
so I stop here. Next day I shall continue from this slide. And you have any problem, if you have any doubt, you can tell me right now.
Okay, sir. Okay, sir.
Okay.
Leave,
can,
sir.
Yes, you can leave.
Okay, sir. Thank you, sir.
Thank you.